Okay, calculus. So next thing we need to do is find the distance between two planes. However, two planes intersect if they are not parallel. So the only two planes that can possibly have a distance between them is two parallel planes. And that means every point on the plane, like they should be either vertically or horizontally separated from each other. So all we have to do is take one point on one of the planes and find the distance to a point on the other plane. So if we take this generalized formula from the distance between a point and a plane, which is distance is equal to ax naught plus by naught plus cz naught plus d over the square root of a squared plus b squared plus c squared, I can just take, this is the same equation from the last one, I can take the point to 0, 0. That's my x naught, y naught, and z naught, and take my other equation and call this a, b, c, and d, and simply plug it into the equation. Distance equals the absolute value of a, 6 times 2, minus 2 times 0, plus 4 times 0, plus 4, all divided by the square root of 6 squared plus 2 squared plus 4 squared. And what do I get when I do this? I get the absolute value of 16 over the square root of 6 squared is 36 plus 4 plus 6, and so over square root of 56, which is about 2.138. Now, why is it this way? Because of the formula, but let's think about a point here. If x is 2, 0, 0, you might think that, well, if I let the other two variables be 0, I should be able to get x is, it looks like 6x would be negative 4, so x would be negative 2/3. But remember, these planes might be going in lines, so you don't want to take necessarily the same x and y and say, well, here's a vertical distance of 2 2/3. That must be how far the planes are apart from each other. Technically, this orthogonal line would be shorter just looking at the triangle, so it's actually closer than you think together. Okay. Now, we can do distance between points and a line as well, instead of just a point in a plane. So the distance between a point and a line in space is the distance is equal to the magnitude of the cross product of PQ cross U over the magnitude of U, where U is a direction vector for the line and P is a point on the line. So if it asks you to find the distance between a point and a line, for example, the distance between the point 3, negative 1, 4, and the line defined by x equals negative 2 plus 3t, y is negative 2t, and z is 1 plus 4t. Let's do this. Okay, so we've got PQ. Again, this is a vector from the point, some point here, to a point there. The easiest point to plug in would probably be when t is 0. So we need to go from negative 2, 0, 1 to the point 3, negative 1, 4. This vector, by subtraction, 3 minus negative 2 is 5. Negative 1 minus 0 is negative 1. 4 minus 1 is 3. It's 5, negative 1, 3. Now we know our line extends in a different direction based on t, so our u are coefficients for t, respectively, 3, negative 2, 4. Now it says I have to do the cross product, so I, j, k. We have our 5, negative 1, 3, our 3, negative 2, 4 between our two vectors. So this is I times negative 4 minus negative 6 minus j times 20 minus 9 plus k times negative 10 minus negative 3. So this is 2i plus minus 11j, excuse me, minus 7k, which is the vector 2, negative 11, negative 7. Now it says I need to take the magnitude of that vector and divide it by the magnitude of my original u, which is the 3, negative 2, 4. So that means I have to take the square root of 2 squared plus 11 squared plus 7 squared. I'm using the positives because it doesn't matter when it's squared. Over the square root of 3 squared plus 2 squared plus 4 squared. That is the square root of 121 plus 49 is 170, so this is 174. Over the square root of 29, which is approximately 2.45 units. So this is the distance between a line and a point, and that is all for 11.5. Now one note on 11.6, it's a lot of attempting to graph problems, sketching graphs, three-dimensional graphs in 2 dimensions. I will not test over it, so you don't have to worry about doing it, so we're not going to do any notes on it, which means this is the end of chapter 11. You can look through the completed 11.6 notes on Canvas if you'd like, but I won't be doing a video on them. That's it.